In this video, I want to provide some tips on getting started with Project 2. Now, I would actually recommend that people try to do that by themselves. That is more useful. However, if you are still stuck, it makes sense to watch this video. So what I would recommend is actually starting with problem 1 from lab 8. Problem 1 from lab 8 is all about figuring out put sequence on board. Put sequence on board is one of the functions that was given to you in the handout code. What's that function all about? Well, it's about trying to put a sequence of color and length on the board. So it's about figuring out how board works exactly as a list of lists, which represents a game board. So what are we doing here? So we're saying initially we're given the start of the sequence and we'll say board at y at x equals to color. We do it inside the loop, but that doesn't matter. This could be outside the loop as well. What we do then is we update y by adding dy to it, and we update x by adding the x to it. And then again we say board at yx equals color. So that way, eventually what we'll have done is put a sequence of this color and of this length, because we put the stone length times, on the board. So problem 1 is just asking you to play around a little bit with this function. It's saying, first make sure that there is not an exact sequence like that already. So that's basically about, instead of doing an assignment here, doing a comparison. And second of all, so it's a little bit more complicated than that, but basically this is that. And second of all, also make sure that there is no conflict where there is some squares that are occupied and some squares that are not. So it's basically doing loops that are in the same style, except you modify small things there in order to make sure that you accomplish those tasks. Once you've figured that out, I recommend that you just go function by function here and implement each one of them in turn. So isEmpty, for example, isn't really that useful for the other functions. IsBounded can be useful if that's what you want to do, if you want to use it. You don't have to use it in detectRow, although I would recommend that you think about how to accomplish that. DetectRows probably should make pretty heavy use of detectRow. SearchMax relies on the score function, which in turn relies on the detectRows function. IsWin we'll talk about later. So what is bounded about? Well, here's an example of a board, and here's an example of an input that you might get. So you might say, okay, so if a sequence ends over here, and the sequence does end over here, and if it goes in this direction, which means the y equals 1 and the x equals 0, because you're not moving horizontally, just moving vertically, and it's of length 3. The question is it open or is it semi-open? So how to check that? Well, what you need to do is you need to say, okay, is there a square here? And if there is a square, is it empty? Is there a square here? And if there is a square here, is it empty? So basically it's a bunch of if statements. And with this bunch of if statements, you can accomplish the task of figuring out whether the sequence is bounded from above, from below, from the sides, and so on, in order to figure out whether the sequence is open or semi-open. So that's isBounded. What about detectRow? So what detectRow is asking you to do is it's saying, okay, so let's say that you have a row that, for example, starts over here. So this would be y start, x start, and then goes in, for example, this direction. And it's asking, okay, so for sequences of color of length, how many open sequences there are that are like that, how many semi-open sequences there are that are like that. How to approach this kind of problem? Well, actually we solved a pretty similar problem before, and that was when we were solving the longest run problem. So what were we doing here, to remind you? We were saying, okay, so let's say that you have a sequence that's kind of like that. So a bunch of A's, maybe a bunch of B's, a bunch of A's again, another B. So what we were doing in this approach is we were saying, let's go through the sequence one by one. So we are going like that. And then when we encounter a character that's different from the character that we're looking at, well, this is this part where we say max run, is equal to max of run max run. So this is saying, well, the run, that's the length of the sequence that we're currently looking at. Now, max run is not something that we're interested in this problem in, but run would be useful because what we are interested in is sequences of a particular length. So you can definitely use this run. So try to look at this kind of thing. This is one possible approach to solving the problem. Now, another difference, of course, is that here what we're doing is we're looking at strings. So this is how you go character by character in the string. Here we're looking at rows, but if you know about put sequence on board, you know exactly how to go through this row because you've already seen put sequence on board. So that's detect row. Detect rows is pretty straightforward. Just if you have detect row, knowing how to use detect rows, that's pretty straightforward. Now we have search max. What's search max? Well, actually, we kind of did search max when we did make computer move attack when we were solving the tic-tac-toe lab in class. This is what it looked like. So to remind you, what we did is we said, okay, so let's try to put the mark at any point in the board, and if that leads to a win, then we return. If it doesn't lead to a win, then we go to this line, we undo the move, and we try again. So search max should be kind of similar in its approach. It's kind of the same. Now, some people wondered about the score, so let me give you just a brief idea of what the score is supposed to be. So here's the score function, not the function that you should modify. So what does it do? Well, the score says return some score for a particular position on the board. And what it says is, well, assume that it's white's move, that black has just moved. And what it does is it returns a very large number if black already won. It returns a very small number if white already won. If black didn't win and white didn't win, then it looks in more detail at what kind of sequences there are. So it says, okay, so it's white's turn. So if white has an open sequence of 4 or a semi-open sequence of 4, that means that white can win at the next move. So we should make the score very negative. And then it says, okay, so if this is like that, then there is really no point at looking at all those other things because 10,000 is so much larger than 550 and so on. Then it says, okay, so if white cannot win straight away, well, if black has an open 4, well, that means that black probably can win at the next move. So that means we should increase the score because the more positive the score, the better the position is for black. The more negative the score, the worse the position is for black. And now it says, okay, so an open 4 is good, a semi-open is not nearly as good. Now let's look at how many open 3s white has. And if white has some open 3s, well, that makes the score more negative. If white has some semi-open 3s, then it makes the score a little bit more negative. And so on. So that's the idea here. And what does search max do? Well, search max looks for the best move for black in order to maximize the score on the board. Finally, is-when is pretty straightforward. Just make sure you understand exactly what you're asked to do, and that's not really difficult. Good luck.